This lesson is solving absolute value equations. So we should remember from our discussion earlier in the semester, an absolute value is the distance from a reference point, and the absolute value of a numerical value is always positive. Remember our discussion about when we measure the distance of something like a shoe size or the measurement of a wall or the height of somebody, we don't ever have -9 feet or anything like that. It's always positive. Now, the steps for solving an absolute value equation is to isolate the absolute value expression. So you would have the absolute value of some stuff equals a number. Or some stuff, but it's not going to have anything on outside of the absolute value bars. That's what isolate means. Then to talk about the possibilities. So if we have the absolute value of some stuff, is what this says. The isolated math expression is some stuff. If we have the absolute value equals a negative number, well, we just said it's always positive. So this means there is no solution because that can't happen. If we have the absolute value of some stuff equals a positive number, we're going to end up with two solutions. And that is because, for instance, the absolute value of something, if it is 3, well, -3 is 3 units from 0, and +3 is 3 units from 0. Now we have the absolute value of some stuff equals 0. Well, there's no positive or negative 0. 0 is just 0. 0 is just 0 units away from 0. So there's only one solution. Okay. So this is the exact example I just talked about on the other side. If I have the absolute value of some number, then that means, is 3 units away from 0. Then that means that number has to be +3 or -3. So if we look at the number line, 1, 2, 3 units away is 3. 1, 2, 3 units away this way is -3. So this number has to be -3 or +3. Now, how do we graph that on a number line? Well, since it's equal to -3, I'll put a point there, or equal to +3, I'll put a point there. Okay. Looking at this one, the absolute value of some number is -2. So what number is -2 units away from 0? Well, that can't be. That doesn't exist. There's no solution. Because there is no solution, we have nothing to graph. The empty number line is no solution, the graph of that. Okay, now we have one that has some extra stuff. So again, you're supposed to isolate the value first, isolate the absolute value first. So here we have it, it is isolated. So what that means is that instead of just x has to be 2, we have x minus 1 equals 2. So again, this stuff is 2 units away from 0. So it has to be equal to 2, or it has to be equal to -2. And that is including all the stuff inside. So we actually have to write that. Now we have a little work to do. So if I add the 1 over, I get x equals 3 here. That's hard to see. X equals 3. If I add the 1 here, then I get x equals -2 plus 1 is -1. Okay, so I have x equals -1 and x equals 3. So this is my graph. So flipping the page, I am looking at my absolute value. Ooh. And that is not isolated. I have this. So before I write my two equations, I have to add the 5 over here so that I am isolating my absolute value. 4 plus 5 is 9. So now it's isolated. Everything left is inside the absolute value. Okay, so this stuff is 9 units away from 0, meaning it has to be equal to 9 or -9. And the stuff inside is 2x minus 7. So let's solve by adding 7. 9 plus 7 is 16. And divide by 2 to get x equals 8. Over here I'm adding 7. -9 plus 7 is -2. Divide by the 2 to get x equals -1. So we have x equals -1 and x equals 8. Next problem. I'm going to add the 6 over to isolate the absolute value part. So I have 2 times the absolute value. 6 plus 4 is 10. A lot of students want to distribute here because that's a habit, but this is not parentheses. This is the absolute value. So we don't want to do that. Let's go ahead and divide it over here and get rid of it. So now we have the absolute value of x minus 8 equals 10 divided by 2 is 5. All right, so now we have some stuff. It's 5 units away from 0. So that's going to be 5 or -5. And the stuff inside is x minus 8. So I'm going to add the 8 over. 5 plus 8 is 13. Add the 8 over here. And I get x equals 3. So the solutions are 3 or 13. Okay, here we are again. We're going to add the 2 to isolate the absolute value. -4 plus 2 is -2. And to get rid of this, I'm going to divide by -1/4, multiply by -4, however you remember doing it. Because of the keep change flip, I can multiply by -4, and that will equal 1. Multiplied by -4 over here. So I have the absolute value of 3x minus 5 equals -2 times -4 is 8. All right. So 8 units away from 0 is 8 and -8. Put my stuff over here. So if I add the 5, I get 3x equals 13. And divide by 3, I get x equals 13/3. So let's go ahead over here. I'm going to add the 5 here. Oops. To get 3x equals -8 plus 5 is -3. And then I'll divide by the 3 to get x equals -1. So here's 0. Here's -1. Now where does 13/3 go? 3 divides into 13 4 times. 3 times 4 is 12, so that leaves me with one more. And so I have 4 1/3 here. So I can do like a 3 and a 4 and a 5, and I'll just put 4 and 1/3 here, and -1 here. And my last example, I am isolating the absolute value. 2 plus 3 is 5, and I'm done. So 5 units from 0 is 5, or -5. I'm going to add the 1 to both sides to get 2x equals 6, and divide by 2 to get x equals 3. And then here, I have -5 plus 1, get -4, divide by the 2 to get x equals -2. So here's my 0, -2 would be over here, +3 would be over here.